All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be continuing learning about protobuf or protocol buffers. This is a really interesting concept, and I'm glad that I came across it and decided to start learning it. Today we are going to be focusing on the Python side. I'm still kind of like either way, I would be learning it on both the Python and the what do you call it? What do you call it? The Python and the Rust side. I would be learning it on both the sides, but I feel like I would be using it a lot more in Rust, especially given the projects that I have planned. So I'm wondering if I should learn the Rust side instead. I did already create this environment, and in this environment, I'm yet to install the protobuf package. The reason for that is because I was kind of confused about how you're supposed to be going about this. Because this Python section, it says, okay, describes exactly what Python definitions the protocol buffer compi the protocol buffer compiler generates for any given protocol definition. Okay, I was expecting this to be sort of a what do you call it? Sort of a tutorial to teach you how to set up the stuff in a Python environment, but that doesn't seem to be the case. So I'm not sure um, how we are meant to be going about this. So I've opened up the language guide here. This covers how to use Proto 3 revision of the protocol buffers language in your project. Okay, does this go into any specific language, or is it language agnostic? So is it mainly focusing on the proto language, the protocol language? What's generated from your .proto? When you run the protocol buffer compiler on a .proto, the compiler generates the code in your chosen language. Wait, compiler generates the code in your chosen language. You'll need to work um, with the message types you've described. Oh, okay. It generates the code needed in the specific language. It generates the code that you will need to work with the message types you've described in your file, including getting and setting field values, serializing your messages to an output stream, and parsing your messages from an input stream. Um, they have not mentioned Rust here. Fortunately, they have mentioned Python. Python. Okay, Python is a little different. The one that I'm going for, the specific one that I'm going for, is a little different. Okay, the Python compiler generates a module with a static descriptor of each message type in your .proto, which is then used with a meta class to create the necessary Python data access class at runtime. Okay, you know what? This is a good point of research. Um, I guess I should go for this. Oh, okay. Yeah, we can go back and back and back, and then, yeah, scratch stuff, empty directory, and let's open up Gemini here. Oh God, for a second there I panicked because I was like, are we about to run into that same issue again? Give me a second. Let me open up my chat in the on my phone. Dude, we also need to get back to learning about Hugging Face transformers, dude. In fact, now would actually be like a much better time for me to. Well, If I'm going to be using it, I should definitely set up a mechanism to run the code on Kaggle instead of having to run it locally. Um, yeah, yeah. Oh, you know what? Google Collab is a thing, right? Does Google Collab give you compute resources? Google Collab compute. Collab paid services pricing. Okay. What up up to what point is it free for you? Let me just look that up as well. Give me a second here. I'm looking it up on another machine. I just remembered I was trying to open up my chat. Give me a second. Okay, okay. And we should be good. Oh, okay. Hey, so I'm learning about protobuf. Oh God, dude. All right, let me just use my other keyboard. So I'm learning about protobuf. And for practice, I've decided to go um, with Python. Oh God, what did you just do? Yeah, okay. Hey, so I'm learning about protobuf, and for practice, I've decided to go with Python. Um, I'm a bit confused here because the docs say something about metaclasses and descriptors. Um, I've done Python for like a decade, but have never um, had to work with these concepts directly. Or rather, actually, no, I have. I'm pretty sure I have. A bunch of other libraries have done this. I shouldn't be saying that. I have had to work with these concepts directly. Um, oh, but have never had to create these myself. I'm guessing a bunch of libraries that I've used before have used these concepts to accomplish various things. Um, for context, I do data science and ML, so I've used NumPy. I'm giving like a whole ass story here. NumPy, pandas, matplotlib, scikit learn, and PyTorch, to name a few. Explain these concepts to me, please. Is that it? I'm confused. I'm a bit confused here because the docs say something about so and so. Okay. Also, once the code, this is another thing that I'm confused about, is that whether I need to actually install protobuf. I'm pretty sure I need to install protobuf because um, I've seen protobuf being part of many projects requirements files. Um, that sounds weird to say. I've seen protobuf in many requirements files in multiple projects that I've explored. Hey Olax, hello, hello, welcome to the stream. How's it going? We are currently we're continuing learning about protobuf, and I've decided to use Python to practice protobuf before eventually going to the Rust side. Right now, I'm just asking Gemini to explain the concept of metaclasses and descriptors in Python because um, I've never had to implement these myself. I'm pretty sure the libraries that I've been using, they have implemented them in some way, shape, or form, or they've used these concepts for various things, but I haven't had to directly create these things. So I would like to understand what they do. Okay, also once the once the generated code no, once the code is generated, do I also need to import to install uh, the protobuf library in my venv to be able to use the generated code? Hold on. Um, Stream froze on my phone. I think it might just be my phone. Yeah, I think it was just my phone. Well, my internet connection as well. But yeah, it doesn't look like we dropped any frames. Also, yeah, this is gonna eventually throw an error, so let me select the model as well, just so it doesn't later throw an error. Because currently, I think so. Gemini 3 came out, and so we have access to Gemini 3 a little bit, and well, for free. And Gemini 2.5 Pro, we get like, a couple of prompts that we can, a set number of prompts that we can do for free per given time limit. And usually, if you hit that limit, then it's going to throw an error, and it's just like all sorts of confusing. Okay, this is our answer. All right, so we are going to learn about metaclasses and descriptors. I feel like descriptors are, I feel like we've looked into that concept. I wonder how different it is from attributes because we have looked into, there was a concept that we had looked into a while back where you could implement these kinds of tags, and the tags, they had like a bunch of, like, the code behind them was different. You wouldn't imagine that this is exactly what you need to do. I forgot what it was called. Hold on, I'm curious now. Python descriptors. I'm wondering if wait, this is Python descriptors are objects that implement at least one of the descriptor protocol methods: get, set, or delete. These methods allow you to customize the behavior of attribute access, modification, and deletion within a class. Okay, I haven't had to directly define get, set, and delete methods, but this seems to be just like a convention kind of thing. Like, okay, you define these, not necessarily a convention, but like one of those things where you define these methods, and once you define these methods, it automatically gives the class certain type of functionality. Like when you define certain methods on a class, and then that class can be used as an iterator, for example. Okay, let's read this. Okay, let's break down metaclasses and descriptors in Python, especially in the context of something like protocol buffers, and then address your question about installing the protobuf library. Metaclasses in Python. Think of Python, sorry, think of Python classes as as blueprints for creating objects. You define a class, then you create and then you can create many instances or objects from that class. Makes sense so far? What is a meta class? Just as a class is a blueprint for an object, a meta class is a blueprint for creating classes. In Python, everything is an object, and that includes classes themselves. When you define a class like this, Python actually uses a meta class by default, the built-in type meta class, to create the myClass object. So myClass is an instance of type. I did not know this. I actually did not know this. Okay, so does this mean that we can define a new way of defining classes? Okay, why use a custom meta class? When you use a custom meta class, when you want to modify how classes are okay, so this is where you modify how classes are created. This means you can automatically add methods or attributes to newly created classes, enforce certain conventions or structures on classes, perform validation or registration when a class is defined. See, this is the interesting thing, right? You can be using a language for close to a decade and still have certain features that you've just never looked into, never touched. Like um the concept of attributes, I forgot what that feature was called. Hold on. Python, it wasn't called attributes though. I don't think it was called attributes. It had a specific name, because like attributes are kind of like members of an object. You can call any variable that you're accessing from an object. You can call it its attribute, right? Any method that you're accessing, you can call that an attribute. Oh, it was done using the at the rate symbol. Um, Decorator, that's what it was called. We learned the concept of decorators. I didn't use it like ever after that, even though there have been situations where I would have been able to benefit from decorators, but it's one of those things that just didn't occur to me. It didn't really. Dude, the thing is, I don't often work on libraries. I'm often working um, on like the final, how do I even say this? I'm not often working on libraries. Let me just put it that way. I'm working on stuff that is meant to do something, that is going to like, immediately do something. I'm not working on libraries that are meant to be used by other people. So there are certain concepts that you usually only feel the need to implement, and so usually you only come across them when you are working on libraries. And it's the same case for a language like Rust. There are certain concepts that, though I have a feeling that with Rust, um, you do get exposed to quite a lot of the functionality even without you creating a library. But there are certain concepts like, okay, you might be exposed to it, but you're not really going to use it all that much, because it's either not required or doesn't make sense, or um, you don't feel the need to use it unless you're working on a library that someone else is going to be using. So I feel like it's a similar situation here, where because in Python I've come across a bunch of such concepts. There was one concept which is still wild to me, where they generate the methods at runtime. I forgot which. I think it was pandas, maybe. I think it was pandas, or maybe scikit-learn. I think no, I think it was pandas. In in pandas, there are certain situations where functions are just being generated at runtime, and because they're being generated at runtime, um, the language server doesn't know what functions to suggest to you, what arguments to give those functions. So you'll run into some situations where you're expecting you're expecting a certain object to have so and so functions and so fields, because you know the type of that object. You because you're writing the code, so you have that expectation that, yeah, this is going to be the type. But in reality, there's a whole lot of like dynamic generation going on in the background, because of which the language server doesn't really know, hey, this is the list of methods, and this is the specific type of this object. These are the methods that are implemented on it, and these are the fields that it might have. It won't know about all the attributes. Anyways, let's continue reading this. Okay, so Python actually uses a meta class by default, the built-in type meta class, to create the my class object. So my class is an instance of type. I wonder if, okay, let me see something here. So let me open up this project in NeoVim, and give me a second. Py01.py. All right. Now here, let's create a class, um, some class O1 pass. Okay. Down here, okay, yeah, print type some class O1. Okay, Python 3.13, this. Okay, class type. See, this is this is one of those things that I never really noticed, never really paid attention to it. If I do, let's say, a equals some class O1, and then print the type of a, it's main dot some class O1. Okay. All right. Okay. Example, simplified concept. Hold on. Imagine you want every class in your data processing pipeline to automatically have a version attribute and a log creation method. A meta class could inject these into every class it creates without you having to manually add them to each class definition. Oh, okay. So the important thing here is that it has to inherit from type, which I'm I'm wondering what type is. Type would be called a class as well, I guess. Can I create something of type? Like how do I even do that? Um, type. This is a method, because like in Python you usually don't wait. Okay, a equals type, but then type. This is again. Oh, wait, no, hold up. This is type, and then this is types. Hold on. That's interesting. Have I been using the, wait, let's take a look at this. Because I was always assuming that this is a method. Type is not a method. Type is a class. But then we use it as a method, probably because it has that one function implemented in it. Python using class as method. In Python, a class method is a type of method bound to the class itself rather than to an instance of the class. Okay, so then I guess technically it is still uh, a method. It's called a class method. This means it can be called on the class directly without without needing without needing to create an object of that class itself. Wait, no, okay, this is kind of like static methods. That's not what I'm looking for. That is not what I'm looking for. Wait, hold on. Yeah, because this is talking about a class method decorator. I'm talking more about, like, for example, in PyTorch, you're able to create a linear layer. This is going to give an error, but just like, yeah, you're able to create a linear layer, and then you can specify whatever shape for it, and then you can call it as a function or as a method. You can call that linear layer thing itself and pass input into it. I forgot exactly what that is called. That's not a class method. That is not a class method because a class method seems more like, hold on, let's try something here. Um, let's say b equals a5. This should give us an error. Not callable. Call. That's the function. Okay. Python call. Call is to turn your instances into callable objects. In other words, its purpose is to create objects that objects that you call. Hold on. Its purpose is to create objects that you can call as you would call a regular function. Most Python classes don't implement this method. Your custom classes will have it only if you need to use your instances as functions. So this is the important part, right? Instances as functions. I need to understand this. I think we need to create a new conversation with Gemini. Let's wait for that to start up. Okay. Um, in Python, I've noticed that we are able to do type. I always thought type was a function, but it turns out it's also a class. But it's not an instance, yet we are able to call it as if underscore call was implemented on it. explain this to me. Also, since we are doing Python stuff, I was feeling kind of lazy to change the logo because I have a Rust thing currently. Also, something else that I noticed is that I feel like uh, this code, this window, I should probably make it slightly bigger, um, just so it's a little more visible. Um, what was I doing? Oh, yeah. Oh, wait. I just remembered. I was supposed to be changing this to um, a Python thing. So give me a second here. Okay, that Python logo is pretty big. We can shrink it down and we should be good to go. Yeah, I think we can make it smaller, I think. Though that big is it's not really that bad. Hold on just a second. Is that cutting off too much of the browser? Wait, I feel like that might be cutting off too much of the browser. Yeah, I feel like that's cutting off too much of the browser, especially because that bottom section isn't really, it's not really holding a whole lot of important information. So I don't think it's necessary. Yeah, that's fine. That's fine. If anything, should probably increase this a little bit because I noticed it while looking at the VODs, while I was uploading the VODs to YouTube. I was looking at the sizes of the windows and, well, more specifically, how legible all of the text was. And in the bottom left, yeah, it's all pretty legible. On the top right, it's kind of legible because I usually like zoom into the page so I can read. But in the middle right, it's kind of legible. It could be better. So hopefully this fixes it. But yeah, yeah. Let's continue reading. There is another thing though. This is going to be blocking off. Well, to be fair, there isn't like there's real estate there. Let's just say that. All right. Of course, you've hit on one of the deepest and most powerful concepts in Python. Okay, this is okay. Metaclasses. Fine. Your observations are spot on, and the confusion is normal because type plays a unique dual role. Let's break it down. The two faces of type. You're correct that type acts like both a function and a class. As a function, when called with one argument, type returns the type of an object. This is the form everyone learns first. It's straightforward. Yep. Okay. As a class, when called with three arguments, type dynamically creates a new class. this is the key to understanding everything else. Uh, Name the class of the name of the new class, then basis, a tuple of parent classes to inherit from, and then dictionary, a dictionary containing the attributes and methods for the class. Okay, what is this supposed to be doing? For example, this code, my class, okay, there's an X attribute, there's a say hello, well, there's an X field and a say hello method, is under the hood essentially syntactic sugar for this. Really? This is, okay, hold on. This is something, this is something new for me. This is definitely something new for me. I had no idea that this is what was going on behind the scenes, and this is kind of why I like to take the effort to understand syntactic sugar, because it reveals a bunch of things about a language that you might have not known before. I've had this kind of a situation with Rust as well, where I was using certain operators or certain way of accessing things, and I didn't know that we have these ways of accessing things because they are syntactic sugar for something that's a little more verbose or something that's a little more convoluted. But this is interesting to know. So my class equals type, my class basis. It doesn't okay, so it doesn't inherit from anything, and then a dictionary of attributes. Yeah, this is crazy. This is crazy because in Python you don't have to create a class in order to create a function. You can just create a function, right? And then when you create a class, then you can implement a method on it. You can create a function within it, which would be accessed through an instance of that class, in which case that function then would be called a method. Um, but yeah, dude, this is interesting. Now we can use my class just like the one we defined with the class keyword. Wait, how long have we been streaming? 40 minutes. Give me a second. I have some food on the flame. I was cooking something, well, slow cooking. I just need to go and check and make sure that there's still enough water in that dish. And basically, I need to make sure that the dish is not burning because all of the water is like evaporated and there's no gravy in it. So give me a second. I'm gonna um um I guess I'll switch to BRB and I'll mute my mic. I'll be back in a couple of minutes. I'll also take a little toilet break. Okay, I'm back. Sorry about that. Um, Took a little longer than expected because I decided to put some potatoes into my dish. So now I'm gonna let that cook for another, I don't know, however long I'm gonna be streaming. I don't know, 45 minutes more maybe. I mean, I have a good like hour more to stream. I actually have 2 hours to stream. Well, no, not 2 hours. I have a good like I have a good like um hour and a half to stream. Dude, what's going on with this application, man? Let me close a bunch of these things and then reopen the Twitch app and reopen my stream. Okay, give me a second. All right. Okay. So, um where was I? Yeah. So, the meta class, a class of a class. Here's the mind-bending part. In Python, classes are objects too. Okay? Since every object must have a type, a class that created it, what is the type of a class? Since hold on. Since every object, okay, classes are objects too. Since every object must have a type, that is a class that created it. Oh, since every object, okay, classes are objects, and because every object has to have a type, what is the type of a class? Class my class, okay, type. The class my class is an instance of the class type. Okay, a class that creates other classes is called a metaclass. Therefore, type is the default metaclass in Python. Think of it like this. You use a class as a blueprint to create instances. You use a metaclass as a blueprint to create classes. Your call question is the final piece of the puzzle. You're absolutely right to think call is involved, but it's not. But it's not where you might expect. When you create an instance of a class like so and so, you are calling the class my class. Wait, init methods init methods can return. Can init methods return? Wait, but this action does not invoke myClass.call. Instead, it invokes the call method of the class of my class. And what is the class of my class? It's type. Oh my god. Okay. Okay. Um yeah, I need to be able to wrap my head around this. This is an interesting concept. I need to play around with this some more. So my class is roughly equivalent to type.call my class. The job of type.call is to call the class's new method to allocate memory and create the new empty instance, call the class's init method to initialize the newly created instance, and then return the initialized instance. Um, okay. Summary, you were right about type. You were right. Type is a function when called with one argument. Oh, hold up. Type dot call. Type dot call would be used. This, I'm kind of, I'm trying to visualize this, but I'm having a hard time visualizing it because it's kind of like a, um, I don't know, like an Inception kind of thing. Not even sure how to explain that. Um, wait. The core concept: classes are objects, and their class is called metaclass. Type is the default metaclass. Type is the default metaclass. Okay. The call inside. You were right that um, the brackets implies call. When you call a class to create an instance, you are invoking the call method of its meta class. Okay, now it's making sense. All right. Okay, now it's making sense. Now it's making sense. This would okay. So wait. Where should I do this? We could probably do it here. Uh, we can get rid of this as well. So we don't need a method here. We can say, oh God, dude. Okay, let's do it here. Okay, my class O1 equals type, wrong key, type with three things. Are we good now? No, we're not good. Okay. Um, this would be called my class O1. Oh, now we're good. Right. What's the next thing? It's these are I'm not sure what this is supposed to. Oh, this is what it inherits from. It inherits from nothing. And then we have to give it a dictionary, which that can be blank as well. So this is an instance of type, and that is why we are able to do my class O1 like this. So then if I do type A, we should get, wait, why did you do that? Hold on. Don't ruin the, because I'm gonna, oh, what just happened? Wait, yeah, okay. Um, let's, I think I need to add a trailing comma, and then we should be good. Yeah, okay. So yeah, if I run this now, then there it is. Okay, so we are able to call this as, right. So okay, wait. What if I do this? Is this gonna give me like a, no. I wanted to see, yeah, I don't think that that would have worked anyways because I wanted to see what that's tracing back to, because it is calling this. This is okay. Okay, so I'm trying to wrap my head around this concept. Just a second. Okay. Um, right. Okay, so I'm trying to wrap my head around this concept. So, um, a couple of questions. Oh God. I forgot I can't do the shift enter thing when I'm in Tmux. Can I do it from here? Nope, can't do it from here either. Oh, control. All right, great, that works. Um, so type is the default. No, wait. So when we use the class keyword, um, what's really happening is that type is being called with 3 arguments. Oh God, dude. Give me a second. Not sure what opened up there, but I need to get rid of that. Okay. What does Control Enter do? Okay. Shift Enter? No. I think Control Shift Enter does that. Okay. Control Shift Enter creates a new, um, it splits the screen and creates a new like shell and stuff. Okay, let's try this again. Maybe I should ask it from here, since this seems to work much better. All right, with 3 arguments. Also, if type, no, okay, if type is the default meta class, can we also use other meta classes? Um, do meta classes, the answer is yes, but like, okay, if the answer is yes, then I might as well say, I assume meta classes have to be defined somewhere. Uh, where and how do we define them? Also, let me add here. No write actions, please. Just info is fine. All right. Um, where and how do we define them? Are we able to use custom metaclasses? If so, how? And then one more thing. There was one more question that I had. What was the other question? There was one more question regarding do I need to learn how to implement metaclasses? What situations would I be using custom metaclasses in? Actually, I can think of situations where um, we could get away with using the regular Python class thing, as in using the type meta class, but instead having a custom meta class could give you a bunch of different functionality by default and make things slightly more convenient. Oh, give me a second here. Hold on. Okay, right. Let's get the answer from Gemini. Okay, all right. Right, so there's a good bit of information here. Excellent follow-up questions. Let's tackle them one by one. Class keyword and type. So when you use class keyword, what's really happening is type is being called with 3 arguments. Yes, that's exactly right. The Python interpreter takes the class name, a tuple of base classes, and all the methods and attributes you define inside the class block, bundles them up, and calls type with so and so to actually construct the class object in memory. Wait, just a second. Just a second. Sorry, I had to reload my stream on my phone so the Twitch UI would stop misbehaving. I actually had to also switch the Wi-Fi adapter on and off because I think I have a feeling it might have been misbehaving because of the internet. But anyways, to actually construct the class object in memory. The class statement is convenient syntactic sugar for this process. Can we use other metaclasses? If type is the default metaclass, can we also use other metaclasses? Yes, absolutely. You can specify a custom metaclass for any class you define. This is how you override the default class creation, defining and using custom metaclasses. Yeah, that was going to be my next question. Oh, wait, does it inherit from type by default? This is kind of like in C sharp, where every single object, even like classes, they inherit from object by default. Like if you try to trace everything back, a lot of those things they inherit from object by default. I think class itself. I think my doubt, like years ago, I looked into this, and I was curious that okay, if you don't, if you're not really inheriting from any classes explicitly when you define your own custom class, then oh, actually, yeah, okay, back up. I don't want to say that every single thing inherits from object. Classes. Specifically, my question was about classes in C sharp. This was years ago when I'd done the research, so I'm kind of mixing things up. Um, it was about classes. My question was that when you define classes in C sharp and you don't explicitly inherit from any classes, then how is it that when you create an object of that class, there's already a bunch of methods and fields that have been created, that have been implemented? And then I found out that implicitly, every class inherits from object. And on object, you have these things defined. That is why your classes, when you create your classes, they also have these methods and stuff defined. Okay, back to this. So, you define a meta class in the same way you define any other class, but with a key difference. It must inherit from type. Oh, that's what's going on here. Okay, I thought this was showing that a regular class inherits from type by default. Okay, that's my bad. Here's a simple example. Let's create a meta class that automatically adds a created at attribute to any class it creates. Okay. Um, so we define the meta class, it inherits from type. The new method of a meta class receives the future class's name, bases, and attributes. Okay, all right. And then we get this. So here's what we can do. We can, instead of doing the time thing, we could wait. How's it getting created at exactly? Wait, let me look at this. Okay, created at. Okay, okay, okay. Oh, okay. There's more output there. Right. So instance equals so and created at so and so. By adding meta class equals timestamp meta, we told Python instead of using the default type to build this model class, use timestamp meta timestamp meta class instead. Do I need to learn this? When is it used? For 99% of Python programming, you will never need to write a custom meta class. This is a powerful but advanced feature. As Python core developer Raymond so and so says, meta classes are deeper magic than 99% of users should ever worry about. Okay? If you wonder whether you need them, okay, that's fair. If you wonder whether you need them, you don't. However, they are the secret sauce behind many common libraries and frameworks. Understanding them helps you understand how those frameworks work. Okay, all right. There's an ABC module. What does this module do? Hold on. Python ABC. This module provides the infrastructure for defining abstract base classes in Python. There's another thing that I've never really looked too much into. Um, an abstract base, an ABC is a class that cannot be instantiated directly. Oh, it's okay. Okay, I'm remembering this from C sharp. Yeah, I have seen this concept in C sharp where it cannot be instantiated directly. It's usually meant to be inherited from. Is that the case here as well? Um, cannot be instantiated directly if it contains abstract methods. Its purpose is to define a common interface or a set of methods that subclasses must implement. Wait, so do you have to inherit from? They enforce a particular structure or contract on classes that inherit from them. Oh, okay, you do have to inherit, and then you have to implement the methods. I'm trying to remember if you had to do, if the rules were similar in C sharp as well. Because yeah, for sure, you cannot instantiate those classes. The compiler itself will give you an error saying that you cannot create instances of classes of type of you cannot create instances of abstract classes. I've Dude, I'm gonna be honest, I've very rarely had to use these features because these features tend to be more towards like the library side. Or if you're creating your own like frameworks and stuff, like much more advanced functionality. I've in C sharp specifically because I've done C sharp for more than a decade. Um, I've very rarely had to touch abstract or virtual classes at all. As in, I've very rarely had to define my own abstract or virtual classes or methods. I don't even know if methods can be, I don't even know if classes can be virtual. I don't remember. And I think the idea behind virtual was that it has to be in the same file, I think. I don't remember. Let me look this up. C sharp virtual. The virtual keyword is used to modify a method property indexer or event declaration and allow for it to be overridden in a derived class. Okay, so I'm remembering completely wrong, and um, I don't even do C sharp anymore, so there's no point in looking further into this. Carrying on, automatic registration, automatically registering new classes in a central registry. For example, you could create a plugin system where any class that uses the plugin meta class is automatically added to a list of available plugins. Code generation and validation, automatically adding methods, checking for the presence of certain attributes, or transforming the class that in some way at the time of its creation, not at instantiation. Okay, all right. You know what? Um, right. So this I can move on. I can move on from that. Um, Going back to this. So now I've understood the concept of metaclasses. So how does protobuf use them? Protobuf generated classes often, actually I shouldn't have closed that. I shouldn't have closed that conversation. There was one more question that I had to ask. Let's open that up again and I'll ask the question. Okay. In Python, when you create metaclasses, um, when you let's say when you create a metaclass, that class must inherit from inherity what must inherit from um, type. Um, this kind of confuses me because when you create a class using the class keyword, um, implicitly it's doing type, name, um, um, bases, and attributes. So if actually I don't think that's what was confusing me. What was confusing? Oh yeah. Well, I'm gonna leave that last bit in there, even though like that's less about this. But okay. So what's confusing me is type is a meta class, but in order to make your own meta class, you have to inherit from this meta class. What does this meta class inherit from? I should rename this stream because this is less about protobuf and more about learning about meta classes and mainly it's been about meta. So far, mainly it's been about meta classes. Yeah, I think I'll rename the thing after stream. Okay, yeah, we're just waiting for the answer. Okay. All right. Excellent and insightful question. Excellent and very insightful question. This is one of the most mind-bending but foundational concepts in Python's object model. Let's break it down. The core idea, inheritance is for behavior. Your confusion is completely understandable because it seems circular. Exactly. The key is to stop thinking of inheritance only as a hierarchy of is a relationships and start thinking of it as a mechanism for reusing and customizing behavior. When you write your own meta class, you are saying, I want to create something that behaves like type, but with the but with but with some custom logic. Okay, the type meta class contains all the essential logic for uh, taking a class name, a tuple of base classes, a dictionary of attributes. Hold on. So if I did, hold on, where should I do it? Here. If I did something like this, would I get like a bunch of functions? Right. Um, there might be a new thing here, I think. Yeah, there's a new thing. So let's try getting help on um, type dot new. Somehow that didn't occur to me. I could have just done that because I have IntelliSense here, um, but it didn't occur to me at the time. Oh, yeah, let's do that. Wait, no, why do I need to do this? I could just use, I could just use this. Oh, that's probably why I need to do it because there's no proper, is there? Nope, nope, there's nothing there. Right. Um, okay. Oh, you know what? What does new take here? I'm confused looking at these arguments. There's CLS of type, and then there's object, and then there's any number of arguments after that. Okay, let's wait, yeah, that's not gonna. Where should I guess we can do it here. Let's open up Python here and then do help type dot underscore new. Is that, yeah, okay. Wait, that's it? Okay, create and return a new object. See help type for accurate signature. All right. Hmm. Okay, okay. Let's move on from this because I feel like I'm gonna just keep getting distracted here. Uh, where was I? Okay, the type meta class contains all the essential logic for taking a class name, taking a tuple of base classes, taking a dictionary of attributes, and assembling these three things into a new class object in memory. By inheriting from type, you get all that complex, low-level machinery for free. You don't have to reinvent the base. You don't have to reinvent how to build a class from scratch. You're simply subclassing the class creation engine so you can override parts of it. All right. Think of it like subclassing a dictionary. You don't have to re-implement hash tables, or I've actually never done that. I should look into, dude. This is something that I remember really being very interested in. Like, I mean, it's been a while now. I haven't been interested in it, but like, I was interested in this like a while back. Sorry, I'm watching Iron Mass's stream, and they're doing an IRL stream where Connor is somewhere in Las Vegas, in some place, Universal Horror Labs, no, Universal Horror, and Connor is getting chased. Yeah, okay. All right. But yeah, I've this is this like I found it interesting how we are able to create like custom collections, custom dictionaries, custom, you know, like you can create your own what do you even call these things? Like dictionaries wouldn't necessarily be called collections, would they? But yeah, you can create your own custom lists and custom dictionaries and add your own like functionality on top of that. But I've never actually done this. They're fucking yelling at him. Holy shit, dude. They're in character. That's crazy. Okay. Um, you don't have to re-implement hash tables or key value lookups. You inherit all that behavior from dictionary, and then you can, for example, override the set item method to print. And oh, something that I have done, something that I kind of looked into was implementing a custom iterator. That is something that I've done, and also like, well, I that's something I've looked into and also practiced a little bit. Um, sorry, zoned out. Right. To print a message every time a key is added. It's the same with metaclasses. You inherit from type, and then you can override its new or init methods to intercept and modify the class creation process. A simple concrete example. Okay, you know what? Hold on. Right. Um, sorry, I'm just a little bit uh distracted here. Not even by the other stream that's running on the other screen. So I'm going to keep this open. Okay, the final paradox. What does type inherit from? This is the final piece of the puzzle. You are correct that type is a meta class. So what creates it? And what does it inherit from? I was about to ask this question. What creates it? What exactly creates type? Um, in Python, everything is an object, including classes, and every object needs a base. Object is the ultimate base class. Every class you create implicitly inherits from object. It provides the default behavior for all objects. Type is an ultimate meta class. Type is the ultimate meta class. Type is what creates all class objects, including the object. Oh, that's crazy. Hold on. The object base class is created using the type meta class. That is that is insane. Okay, including the object class itself. Here is the circular mind-bending relationship that is hard-coded into the core of the Python interpreter. Type inherits from object. You can prove this. Is subclass type so and so returns true. This is so that the type object itself can have standard object methods. Backup. No, no, no. Hold on. Can have standard object methods. This is so that the type object itself can have standard object methods. What does is subclass like? What's the left one? What's the right one? Let me. Uh, okay, is subclass. This is not helpful. This is not helpful. Um, yeah, let's do this. Okay, all right. Returns whether CLS, which is the left side, is derived from another class or is the same class. A tuple, as in is so and so, may be given as a target to check against. This is equivalent to is subclass so and so, is subclass that. Oh, for checking against multiple subclasses or checking against multiple classes that have been inherited from. Is derived from. Is derived from means it inherits from, right? I'm assuming. I'm assuming that's true. Um, is there an inherits from class? Inherits from method? No. Okay. Is subclass. Is subclass type and object. Where's the answer? Oh, there it is. True. All right. So object is an instance of type. You can prove this by saying so and so. This is because object is a class. Okay. So A equals object. We can just create an object. A dot, then we have a couple of functions, right? Okay, we can print A. Object at so and so. Yeah, I would have to do type class object. All right. Then type is an instance of itself. Um, okay, this also returns true. This is the bootstrap condition, an axiom on which the whole system is built. Wait, I'm gonna need you to explain this in a bit more detail. No analogies, please. Just info is fine. Um, in more detail, because it's kind of blowing my mind that um, type inherits from object, but object can only be constructed using type, but also type is an instance of type. Okay, so let's see what response we get. And there's something else that I have to do in the meantime because my food is pretty much ready. I'm just gonna go cook up some rice and then eat that. But here's what we're gonna do. What is this? Focus and fantasy. Study with me in a magical mood. Um, just a second. I'm just looking for somebody to raid right now. Um, give me a second. I'm seeing if there are any specific streams that catch my attention. All right, you know what? We're gonna go to this person. Um, their name is Kenzie K and then a bunch of numbers. So we're gonna go check out this person's stream. I'm actually probably not even, I shouldn't even say like check out because I'm gonna raid and then go for my food. So I'll just say hello to the person real quick and then yeah. So that's gonna be it for today's stream. Guys, thanks a lot for hanging out. Olax, thanks for stopping by. Thanks for hanging out. Anyone else who might have been lurking in the chat, thanks for hanging out. Any What was I saying? Oh yeah, dude, we've got a pretty good streak going here. Like I've been looking at the past like VODs and stuff, and we've we've been streaming pretty much daily for the past like 2 weeks, I think, and that's pretty good. That's pretty good for me. Like considering how easy it is for me to just all of a sudden uh, n- just 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 get into a sort of get distracted with something else and then not be able to stream. How easily that happens for me. We've been doing pretty well, and I'm happy about that. So, that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.